Hi guys, Dr. B here. So today we're going to talk about the classification of matter. This video is not that very long, so hopefully I will hit right below the 10-minute mark for this one. So the topics we're going to cover in this video briefly is about matter, substances, types of mixtures, the difference between elements, molecules, and compounds. And also I forgot to type out something called the kinetic molecular theory. So some definitions to kind of clear things up. Matter is anything that has mass and takes up space. A substance is matter that has a uniform and definite composition. If something is a pure substance, all of the particles are identical. So like if you hear something is pure, some people think of certain things, and one of the things that tends to come to mind is like in TV shows and movies when they talk about drugs being pure. That term would mean that all the particles in that drug, in that whatever you want to call it, are all identical. Sometimes if things are cut with something, that means that substance is no longer pure anymore. We could talk about that when we're in class, on the day you're supposed to be in it if you want to. So a substance can't be considered a mixture if there are different types of particles present. So matter is anything that takes up space, it has mass. Substance, kind of below matter, is matter, and it has a uniform and definite composition. If it's pure, it's all the same. If it's a mixture, there are different types of particles. So different types of mixtures are heterogeneous or homogeneous. So heterogeneous means it's not completely uniform, and homogeneous means it's completely uniform. And we'll go through some examples, and it will make sense once we see them. So this is a bowl of salad, obviously. So this is a mixture because it contains different things. So when you look at it, obviously it's not all the same composition. You can tell what the things are, so that makes this a heterogeneous. I don't like that color. Let's do a different one. Heterogeneous mixture. This is a really bad picture of a glass of lemonade. Let's say it has a lemon juice, the citric acid, the sugar, whatever it may be. You look at it, you cannot tell all the different things that make it up. Therefore, this can be an example of a homogeneous mixture. And do not abbreviate these words the way that some of you will most likely do. Do not do that. Again, so bottles of Gatorade, you look at it, you know it's made up of electrolytes, it's made up of this, it's made up of that, and you can't really tell, you can't see those different particles in the container, in the mixture. So that means Gatorade is a homogeneous mixture. That looks really good. Trail mix, this is my favorite version. Do not judge me. I swear, do not judge me for this being my favorite type of trail mix. So again, it's a mixture, obviously, but you can tell the different parts that make it up. So this is a heterogeneous, can't even spell. All right, heterogeneous mixture. So getting into the nature of matter. Again, I feel like we're all over the place with this, but again, we're actually getting into the chemistry, if you will. So we'll get into more details about protons, neutrons, and electrons, especially electrons. But the basic building block of all matter is the atom. The different parts, the nucleus, which is made up of protons and neutrons. So all that is a nucleus, and then electrons, in this model, they orbit the nucleus. We'll also get into atomic theory. We'll get into the different models there are of atoms, etc. And I think, is part of the fun of it as well, in terms of talking about the atom. So what is an element in terms of chemistry and all that? So an element is a pure substance made up of only one kind of atom. So when you look at the periodic table, you see a symbol or a letter that says what this atom is. There's different ones. Again, you don't have to memorize these, just so you know. But you will know how to spell it because I'm giving you the spelling in this list of the different elements and all that type of stuff. The singular number like this can be 1, 2, 3, 4. That is the atomic number, and that tells you how many protons there are in that particular atom. So this hydrogen atom has 1. The atomic weight, which tells you how much the atom weighs, 1.0079. Again, you won't have to memorize these, but you should know what these numbers mean. And you'll use especially something called the molar mass quite frequently in terms of chemistry. So what is an element? What's a compound? Elements cannot be separated into simpler substances by a chemical means. Compounds are a substance that can be, and they have at least 2 different types of atoms. So the difference between element, notice how this here actually has H2, but it's only one type of atom. So technically, this is an element. Compounds have to have at least 2 types of atoms. So an element cannot be separated into substances by chemical means, while a compound can. So this is an important statement right here that you need to keep in mind. All compounds are molecules, but not all molecules are compounds. So a molecule is formed when 2 or more atoms join together chemically. So notice how a compound can be a molecule because it has 2 or more atoms joined chemically, but the trick is that it can only contain at least 2, it has to contain at least 2 different elements at the very least. So H2O, CO2, CH4, these are compounds, but they can also be considered molecules because they contain 2 or more atoms joined together. But for example, N2, or it's in the name, but N2, like this, molecular nitrogen or dinitrogen, I guess is what you can also call it, which we'll talk about later on in the school year. This is a molecule, but this cannot be considered a compound because it does not contain at least 2 different elements. As I mentioned in the beginning, kinetic molecular theory, this is kind of, again, the lecture seems kind of random, but we're talking about states of matter or different types of matter, / substances versus not substances versus mixtures, what's a mixture, etc. So gas particles. So this state of matter, if you will, this kinetic molecular theory shows and talks about how individual gas particles interact with one another. The average kinetic energy of a gas is proportional to the temperature. So that means that they're related. So if the temperature increases, most likely the energy will increase as well. And when we come into class on your day, you're supposed to be in class, we're going to do a demonstration, and we should also be able to do a kind of a simulation, quote unquote simulation, in the classroom as well. So that is the end of this lecture. Hit that like and subscribe button, and I'll see you all in class. Bye.